Good day everyone, my name is Lerato Molebatsi from Northwest-Universiteit Science Center. I'm the Science Center Manager. Our vision here is to identify, encourage, nurture and support innovative talents in science, technology, engineering and maths. And our mission is to educate and promote STEM by engaging schools and the public. The Science Center programs are career awareness, science awareness, STEM competition, robotics, curriculum support and guided tours at the Science Center. We will be hosting National Science Week from the 1st to the 6th of August. You may wonder, what is National Science Week? National Science Week is an annual event whereby scientists are given platform to showcase their work and promote STEM while engaging with different target groups. The theme for this year, we are celebrating the role of basic sciences in modern world. Through basic science, researchers try to answer fundamental questions about how life works. So you may ask yourself how, because during the pandemic we were struggling to get the vaccine for COVID-19, but through scientists and researchers we were able to get vaccine and it saved a lot of lives.
Good day everyone, my name is Mposieta. I am an intern at the Northwest-Universiteit Science Center from the Department of Science and Technology. We here at the Science Center take pride in making sure that science learning is fun and interactive for learners and surrounding communities. And here we house a science center that is filled with multiple apparatus and instruments that are made interesting to help learners come into the careers of science. Here at the Science Center, when you enter, we have a register which we use for purposes of the Department of Science and Technology. From there on, we have a range of apparatus and instruments that we use just to keep learners and the general community entertained. We have a range of equipments that are made to keep both children and learners and students interacting within the Science Center. These are the interesting exhibits that we house within our Science Center. From here on, I will be giving over to my colleague Garabo, she will now be demonstrating one of our key focuses, which we are focusing on for the National Science Week. Thank you.
Greetings everyone, my name is Karabotoba from Northwest-Universiteit Potchefstroom. I work as a disaster intern. One of our practical experiments you can learn in our science center and relate it on a daily basis is bicycle energy. Since our theme is the role of basic science in combating energy and our topic is energy conservation to reduce carbon emission and save power. When we review the first law of thermodynamics, which is the law of conservation of energy, we say that energy is always conserved. It cannot be created or destroyed. In essence, energy can be converted from one place to the other. Okay, when we say energy is conserved, we simply means that energy is effective to use less energy. When we lower the amount of energy we use, we minimize the burning fossil fuels such as natural gas, oil and coal, and it helps us to clean up the environment. According to the scientists who reviewed the stats of Africa Power that supported the development of 3,180 megawatts for electricity generation project in South Africa, the percentage for electricity produced by power plants is approximately 90%. However, the percentage shows variance of energy generated in South Africa by burning fossil fuel as power plants since it supplies to cars. In addition, other power plants are a result of mechanical engines and backup generators, where most power plants use one or more generators to convert the mechanical energy into the electrical energy in order to supply power to electrical grid for society's electrical needs. In our presentation, we're gonna use some of the household appliances, which is the number 1 of the fluorescent light, number 2 the light emitting diode, which is the LED red light, number 3 the monochromatic TV, 4 electric kettle, 5 the electric fan, in order to demonstrate the energy consumption and emphasize the importance of the household appliances in a smart way. This can be applied in computer science as the application of the Internet of Things, called the smart home because of the energy efficiency. Here we have a mechanical and electrical setup. The bicycle is connected to 12-volt multi-alternator that generates the current to power up the household appliances. The purpose of our alternator is to convert the mechanical energy into the electrical energy in form of the alternate current. An alternator is a type of an electric generator used in a modern automobiles to charge the batteries and supply power to the electrical system. So in this case, we're gonna use the wire and the switch to power up the household appliances. On our alternator, the output of alternator is the direct current, which is the DC. An alternating pulley is when it's rotated in magnetic field, the alternating current will pass the magnetic field, then the electrical current will be generated. Now this is converted to the direct current via the rectifier. Back to our setup, we switch on the large white switch, whereby the field coils of the alternator are now powered. Then we choose which one of the appliances we want to operate: the fluorescent light, the LED, the monochromatic TV, electric kettle or electric fan. Now we pedal. When pedaling, the alternator coil rotates in the magnetic field. Electric current is then generated. This current goes through the appliances we have selected. As we can see, the fluorescent light is on. Moving forward, we wanna demonstrate number 2. We switch on the large white switch. The field coils of the alternator are now powered. Then we choose the second one, which is the LED red light. Now we pedal. The alternator coil rotates in the magnetic field and electric current is generated. This current goes through the appliances we have selected, as we can see. Make sure that the switch is still on. Then choose the monochromatic TV to operate. When pedaling, the alternator coil rotates in the magnetic field and electric current is generated. This current goes through the appliances we have selected, which is the monochromatic TV. As you can see, the monochromatic TV is power up, is on. Make sure that the switch is still on. Then number 4, the electric kettle. Now we pedal again. The alternator coil rotates in the magnetic field, an electric current is generated. The current will go through the appliances that you have selected, which is the electric kettle. We still make the switch on. Now, number 5, the electric fan. When pedaling, we make sure that the current goes through the appliances we have selected, which is the electric fan. As you can see, the fan is on. What conclusion can we draw from this experiment?
Basically, what I learned from this experiment is that there was a difference in the effort required to pedal the bike as I moved around on the switch. It was much more easier to power up the household bulb, and it was much more easier to power up the LED light. However, there was increase in the effort required to power up the monochromatic TV, the kettle, and the fan. In conclusion, what we have learned from this experiment is that we should develop smart ways of using our electrical appliances sparingly in order to reduce the burning of carbon fossil fuels, and also that could serve as means of combating climate change.
To close off our National Science Week, we at the Northwest University Science Center would like to say thank you, and we are asking that anybody who is going to be part of our celebration visit our website, which will be listed down below.
Thank you!